Quick check. You catch a cookie smell and think, cookies. Which part is sensation and which is perception? You've got 5 seconds to lock in your answer. Go. The answer is B. The smell itself is sensation, while recognizing cookies is perception. In this video, you'll learn what sensation and perception are. Follow how signals travel from receptors to the brain and compare concepts like absolute and difference threshold, adaptation, constancy, and top-down versus bottom-up processing. Let's begin with sensation. Sensation is detecting energy in the environment and transducing it into neural signals. Specialized receptor cells convert light, sound, pressure, chemicals, or odors into electrical activity that the nervous system can use. By contrast, perception is identifying and interpreting those signals. It's how the brain organizes sensory input into objects, events, and experiences. To understand the pathway, most senses first route through the thalamus, the brain's relay station, before reaching specialized areas of the cortex: occipital for vision, temporal for hearing, parietal for touch, and gustatory areas for taste. However, smell is an exception. Olfactory signals initially bypass the thalamus, traveling from the nose to the olfactory bulb, then directly into brain areas like the amygdala and hippocampus. This is why odors are strongly tied to memory and emotion. Now, let's take vision as an example. Light reflects off a mug and strikes your retina, where rods and cones convert it into neural signals. That's sensation. Your brain then processes those signals and recognizes the object as a mug. That's perception. Here's another example. Imagine hearing a phone ring. The sound waves enter your ear, and the receptors in the cochlea convert them into electrical signals. That's sensation. Then, your brain interprets those signals as the sound of a phone. That's perception. In practice, sensation depends on receptor limits, while perception draws on attention, context, and prior knowledge. In other words, neither process is purely passive. So far, you've defined sensation and perception, traced the routing pathway, and seen 2 examples. Want to check your progress? Tap the link for a quick practice test and a concise study guide tailored to this lesson. Quiz yourself, skim the highlights, and jump back in. Now, let's move to thresholds. How we detect faint signals and notice differences. The absolute threshold is the smallest stimulus intensity you can reliably detect, such as the quietest tone you can hear. On the other hand, the difference threshold, or just noticeable difference, is the smallest change you can detect. For example, a 1-pound shift is obvious near 1 pound, but barely noticeable near 50. Next is sensory adaptation. With constant stimulation, receptor response falls, so perceived intensity fades, like a smell you stop noticing after a few minutes. Another key concept is perceptual constancy. This allows you to recognize familiar objects as the same size, shape, and color, despite changes in distance, angle, or lighting. But perception isn't only about stability. Sometimes it's also shaped by what you expect to see. That's where perceptual set comes in, a readiness to interpret input based on prior knowledge, which can help, or sometimes mislead. Overall, perception blends bottom-up data with top-down knowledge. Raw sensory input builds the scene, while expectations and context refine it. Let's test this. Hearing a bell is a sensation. Realizing it means lunchtime is perception. And if your stomach growls, that's a physiological response. As we sort examples like these, it's important to avoid common confusions. For instance, constancy is a perceptual correction, not a receptor change, and adaptation is sensory. Getting better at a task over time is learning, not adaptation. To recap, sensation detects and transduces energy, while perception organizes and interprets it. Most senses route through the thalamus, except smell. Thresholds set what we can detect. Adaptation reduces response to constant input. And constancy and perceptual set show how top-down processing shapes what we perceive. Ready to quiz yourself with the content covered in this video? Check out the link in the description where you'll find Quizlet content made just for you.